This video covers examples to assist with reviewing some of the main exponent rules. I encourage you to pause the video throughout and try the questions on your own. Now let's get started with the examples. Now we're going to cover some of the problems involving exponents. For number 7, we can see that we don't have any plus or minuses in between the parentheses, so therefore this is a multiplication problem. Recall that when we multiply terms like these, we multiply the numbers in front, so -2 times 5 will go in front, and then we multiply all the common letters together, so x squared times this x, and y to the 4th times this y, and then we have a z cubed. So simplifying this, -2 times 5 is -10, and when we're multiplying exponents that have the same base, we add their exponent. So x squared times x to the 1st equals x cubed, and y to the 4th times y to the 1st equals y to the 5th, and then we have a z cubed here. So that represents the final answer to this problem. For problem number 8, we can see that we've been given a rectangle, and they are asking us to find the area of the rectangle in polynomial form. So we have area equals length times width is a formula for area of a rectangle. So in this case, if the length is 10x to the 6 feet and the width is 7x to the 4th feet, then we just multiply the 10 times 7 out in front to give us 70, and the x to the 6 times x to the 4th have the same base, so we can add those exponents. The unit is feet times feet, which is feet to the 2nd power, also known as square feet. So that's the final answer for this problem. This next problem involves the power rule for exponents. We actually have a couple different ways we could do this problem. By applying the power rule, we will want to multiply the exponent in on each of these variables. So the first factor is a -6, and all of that, including the negative, will be at the exponent 1 times 2, which is 2. So that'll end up being -6 times -6, which is 36. For the a term, we will have a to the 5th to the power 2, and using the power rule, we can multiply those exponents to get a to the 10th. Similarly, b to the 4th to the power 2 is b to the 8th by multiplying 4 times 2, and the c is c to the 1st to the power 2, which is c squared. So that's the final answer. We could have done this problem a different way. Since it's a square, we could have just multiplied -6 a to the 5th, b to the 4th, c times itself, -6 a to the 5th, b to the 4th, c. -6 times -6 is 36. a to the 5th times a to the 5th. Now that we're multiplying, we add exponents, so a to the 10th. b to the 4th times b to the 4th is b to the 8th, and c to the 1st times c to the 1st is c squared. So either way, we get the same answer. Number 10 involves the power rule as well as the quotient rule. I'm going to apply the power rule first. -4 to the 1 times 3 power times x to the 3 times 3 power, and y squared to the 3rd power, and z to the 3rd power. So this is just applying the power rule to the numerator exponents, but we also have to apply it to the denominator exponents. So z to the 5th to the power 3. This will simplify to be -4 times -4 times -4, which is -64, x to the 3 times 3, so x to the 9th, y to the 2 times 3, so y to the 6th, and z to the 1 times 3, so z cubed, all over z to the 15th. At this point, we should realize we have z terms in the numerator and the denominator that need to be simplified. So in the numerator, we know we will end up with this. We just need to figure out how many z's we have left over and where they belong. If you recall, when you have z cubed over z to the 15th, you subtract the exponents down. So z to the 3 minus 15, which is z to the negative 12, and our negative exponent rule says z to the negative 12 is the same as 1 over z to the 12th. So we could see that the z to the 12th will remain in the denominator. So this right here will be our final answer. Another way to do that without having to go into negative exponents is just to realize that you have z times z times z in the numerator for z cubed, and in the denominator you have 15 factors of z. If you were to cancel 3 of those, 12 of them would be left over in the denominator. So that's the final answer to this problem. This next problem is asking us to find the volume of a cube, and they're giving us side lengths 3y to the 4th. Since a cube is kind of like a square but in 3 dimensions, all 3 sides will equal 3y to the 4th. So we just need to keep in mind our volume formula for a cube, which is length times width times height, or side to the 3rd power, since all 3 of these are the same length. So basically the volume will be 3y to the 4th times 3y to the 4th times 3y to the 4th, which is 3 times 3 times 3, 27, y to the 4 plus 4 plus 4, y to the 12. Since volume is in cubic units, we will put inches to the 3rd power on our answer. Number 12 is another exponents problem in which they want us to simplify this fraction. We could simplify the 5 over 35 by dividing both of these by 5. We would get 1/7. D squared and d squared are the same because they're both d times d, so both of those will cancel out to basically be 1s, and subtracting the exponents down, so 10 minus 4, which is c to the 6th. Since it's a positive exponent, that will remain in the numerator. So in the numerator, we have 1 times 1 times c to the 6th, which is c to the 6th, and in the denominator, we have just the 7 left over because these two simplified to be c to the 6th. So our final answer is c to the 6th over 7. I encourage you to try all these problems again and see if you can verify them on your own. Thanks for watching this video. Please subscribe for more math tips.